So let's jump right into memoization. So I always think of this as one of those kind of intimidating words that is probably on your list of things you're supposed to learn about at some point, this never-ending list that we have as developers. Don't worry if that is you, because I'm going to go through it right from the simplest fundamentals with a JavaScript example all the way up to how React has implemented this with various utility methods that they have on offer. As an aside, since we're now living in the future, 2023, I'm only going to be discussing memoization for React functional components and hooks and not for class components, but it does have equivalent utility methods for class components. So what the heck is memoization? At its absolute simplest core, it's a caching technique. It's a way of keeping track of results and feeding them back, basically. So let's imagine we have a function or a calculation that we run, and we run that for a given input, and it gives us an output. So what we do with memoization is we save the input as the key and the result as the value in any kind of data structure, or like say an object if we're talking about JavaScript. So the next time that same calculation is run or that same function is run with the same input, we first look in that data structure and ask, has this already been run at some point? Okay, yes, I can see that it has. So in that case, just serve me back up the result that we got that time rather than rerunning the calculation. And that's literally it. That's literally all that memoization is from a fundamental perspective. And it's called a performance optimization because you don't actually need to use it in order for the code to work, right? We can rerun that same calculation for the same input every single time. The code is still going to work, even though we might lose out on some performance or memory optimizations. Let's move on. So let's try and implement that in vanilla JavaScript. So we start at the top by instantiating a constant, which is an object called values. And then we have a function, and all that function is doing, or the main thing the function is doing on line 4 is it's taking in any number and it's adding 1 to the number and giving you back out. So we've called it add 1. So if I put in number 5, it will give me 6 back, right? So what's the rest of it? What we're saying is that if the first time I put in the number 5 into this function, on line 3, we're asking, does the key 5 already exist in our values object? It doesn't, so we get back an undefined as the result, in which case we enter into the if clause on line 4, and we say 5 plus 1 is 6. So save that result 6 against the input of 5, or the key of 5 in the values object, and then return whatever the result is against the key of 5, which is 6. So let's say we run this again with the number 5 again. This time on line 3, we look for the key of 5 and we find that the result already exists, which is 6. So we don't run line 4, we just immediately serve back the result from, which is 6, from line 6. So this way we've avoided making this calculation. So computers probably at this day and age don't have that much difficulty adding 1 to a number. But as an example, you could imagine a large complex set of calculations we have to run over a large set of data, factorials, like some kind of expensive calculation instead of adding 1 to a number. And that's when memoization can become useful. So let's try and transpose that into a React example. So here we have a functional component called add1, and you can see at the bottom, it's the same thing. We're just returning a div with the result of whatever the prop that was passed in add1. There are a couple of different ways you would use memoization in React. This is the first example where, again, it's basically not wanting to rerun some kind of expensive calculation while you're rendering your React application. So again, it could be sorting a huge number of data, a huge set of data, something like that. However, there is a problem with this implementation, which is what happens when this functional component gets re-rendered. If I pass in the number 5 and return a div with the number 6 on it because we've added 1. If I then re-render the component and pass in 5 again, that's not going to work, or it's not going to have memoized correctly. So I'll give you a second to think about why. So the reason why this doesn't work in React is because re-rendering basically reruns all of the code included in the functional component. So your constant values object, which is an empty object, every time add1 is re-rendered, all the code reruns, and so the values object gets re-instantiated to an empty object. That means the last calculation you run, 5, and then added that into the values constant, that no longer exists because it's empty again. So on every re-render, the values constant is re-instantiated into an empty object, and you're getting no memoization. You're not retrieving the result because there are no results every single time it re-renders. This is like a little teaser of why the second half of my title is you ain't gonna need it. So, you know, sometimes we're attempting to do something fancy with memoization or other kind of performance optimizations, and we've added all this extra fancy code, and it isn't actually doing what we think it's doing. So how does React help us out? The first hook or utility method that we're going to look at is called use memo. So this time you can see it's the same concept. We have a constant which we've called calculation, got rid of the values object because React is maintaining a cache for us. And what we give in the first argument that use memo is a function, which is our num plus 1. So the prop num, add 1 to it. Again, if you put in 5, it will give you 6. So the way that this would work is that if I re-rendered a second time and the prop num was still 5, React is now maintaining this cache for us. And what it does is it takes its dependency array, which is the second argument here, and it says, okay, my piece of data that I'm dependent on is this variable called, or this prop called num. Has num changed since the last time that this memoization or this use memo was run? So if we re-render it a second time with a num of 5, React says, okay, the dependency is 5 versus 5, so it hasn't changed. So I don't need to rerun my calculation. I can just serve you back whatever the result was for my last calculation, which is 6. So again, we are returning a div with the number 6 on it. So a big difference here is that we're not maintaining a object like we were in the vanilla JavaScript example, where we could fill out the object with as many keys as we wanted. This use memo only maintains a cache based on its dependency. So in other words, it only maintains a memoization result of one thing previously. So let's say that I render this functional component again, this time with the number 8. So the dependency piece of data called num has now changed from 5 to 8. So React sees that it's changed. It says, okay, I need to rerun the calculation, the use memo function, because the dependency has changed. So now 8 plus 1 is 9. So the calculation becomes 9. If I then re-render again and go back to 5, React has no memory that I ever ran 5 in the first place. So it will see that 8 has changed to 5. The dependency's changed. It will rerun the memoization calculation again. So this obviously has an important caveat to it, that this kind of memoization is only useful when the dependencies do not change, or the things that the use memo is dependent on does not change between re-renders. If your dependencies are changing a lot, then it invalidates the memoization because it will just keep getting re-triggered anyway. And the React docs say what counts as an expensive calculation in this context. They say that in general, unless you're creating or looping over thousands of objects, then it's probably not worth using this use memo utility to save on expensive calculations. So there is another use for the use memo hook, not just for expensive calculations. And this is actually within dependency arrays. So as we said, whenever a component gets re-rendered, all of its code reruns. So here we have a use effect, which, as you probably are aware, means that after the component has rendered, some side effect is run, whatever is contained within the use effect. And here we are defining a constant number of 1, and the use effect has a dependency on that number 1. So if my function gets re-rendered, so here there's, we're ignoring there's not really any props, and we're just returning a div that says here for the giggles. The dependency of the use effect is contained within the function component itself. So let's imagine add1 gets re-rendered, gets re-rendered, gets re-rendered. Do you think that the use effect gets re-triggered every time the add1 functional component gets re-rendered? I'll give you a second to think about it. So the answer to that is no, it does not get re-triggered on every re-render of the add1 component. This time, this is something to do with JavaScript. So JavaScript in its dependency arrays and in general, when it's comparing two things, if it is a number like 1, so it will say, does 1 still equal 1? Yes, it still equals 1. So my dependency has not changed from the last render 1 to the new render 1, right? That hasn't changed. So the use effect will essentially never get re-triggered in this contrived example. It will, trigger once on the first render, on the initial render, and then never again, because the number 1 is never going to change and it always has equality. In this example is exactly the same, except this time we've changed the constant from being the number 1 into an object, which contains a key of num and a value against the value of 1, right? So this time it's an object. Same question. Every time that add1 re-renders, does the use effect get triggered or not? So this time it does get re-triggered on every re-render. So this is a bit of JavaScript revision. In JavaScript, we have the difference between equality of primitives versus object types. Primitives, so I'm looking at the right-hand side at the moment. So types of primitive in JavaScript are Booleans, numbers, strings, null and undefined. Object types are arrays, objects, and functions. So if we look at the left-hand side at the top, primitives are compared by value. So the Boolean true equals a Boolean true, the number 1 equals number 1, and the string A equals the string A, even though these are, different pieces of data in our program, right? They, in JavaScript, have referential equality. That's different for object types. So arrays, objects, and functions, even though they look exactly the same to us humans, when they're instantiated with a specific reference. And so the reference on the left-hand side is different to the object that's been created reference on the right-hand side. They're two different references, and JavaScript says that they are not equal. In kind of pernickety caveat, or I guess like extra point within all this, is that if you assign an object to a variable, in this case I've used var, but obviously in modern days that would be const usually, that variable maintains a reference to the same objects that you've created. So when you compare the variable to itself, it's comparing the same reference of objects, so that will give you equality there. So coming back to this example, whenever add1 is re-rendered and the code is rerun, the const mynums gets reinstantiated. So it gets instantiated, completely recreated with a new reference. That means the use effect asks, is the old object reference the same as the new object reference? And it says, no, they're not the same. The piece of data has changed. Therefore, my dependency has changed. Therefore, I need to rerun this use effect. So in this contrived example, the use effect runs on every single re-render, and basically effectively renders this dependency useless because it's just going to rerun every single time. Okay, so this is the second place that useMemo is useful. In this example, we've got exactly the same example, except this time I've wrapped the object in a useMemo. So the first argument you can see here is a function that just returns exactly the same object we had in the previous example with one key against the value of called num, which has got a value of 1. And we've got the same use effect. So this time we're saying that on the first initial render of this functional component, the mynums const gets instantiated and it gets memoized, and we'll come on to what this empty dependency array means in a second, but essentially this never gets reinstantiated. Every single time that add1 gets re-rendered again, the memoized mynums constant gets returned again and again. So it's the same object reference, which means that now the use effect has the same object reference on every re-render and will never get re-triggered, just like when it was a primitive number 1. Recap of how dependency arrays work in React. So we've already seen on the bottom one here that when there's a piece of data, React is detecting that dependency. Like when any of the pieces of data in the array change, that's in the manner that we've just seen, then rerun the use effect or whatever the dependency array is for. If it's empty, that means run once on the initial render and then never again. And if there's no dependency array at all, then that means rerun on every single render. So because we've got an empty dependency array here, it means run this memoization on the first render and then never again. And just for your knowledge, the 4 most common types of React hooks that actually use dependency arrays are use effects, which you're probably well acquainted with, use memo, which we've just seen above here, and use callback, which we're about to come on to, and then another kind of similar thing to use effects, which is called use layout effect. So I'm not sure what any of your experiences are with React so far, but it may be, but in most React programs, we use a lot of use effects, right? So it may be slightly surprising how little we use memo if we want to use objects and arrays and functions as our dependencies of use effects, right? Because they're essentially a lot of the time useless if we're not using this use memo technique to memoize the objects and arrays, right? And the reason that we don't see much use memos is because in order to code in a clean way in React, we often won't actually pass entire objects to be the dependency array of things. And one way that we get around that is by destructuring, the object or array into its primitive parts. And that way, you can much more cleanly base the use effect on the primitive numbers or strings or whatever, rather than the entire objects or arrays. And usually you're going to want to do that if you can before you attempt to memorize objects and arrays and use them as dependencies. So this kind of all speaks to the first example of a general principle that you should always strive to clean up your React code first before applying complex performance optimizations like memoization. We'll cover this in a bit more detail later. So on some very rare occasions, it may be impossible to avoid using the object or array as the dependency, in which case I think it would be appropriate to use memo. Although there is one caveat to that, which is that in general, React is very fast and is built to be optimized for rendering components quickly. So even if your use effect or whatever is getting triggered on every re-render, that might not actually be causing performance problems. So even then, you'd maybe want to consider what the trade-off is of making your code more complex. Okay, so we saw that with the object mynums, you can use memo to memoize objects. So this is just an example here called myArray, where we're memoizing an array. You can see it's exactly the same kind of idea. The first argument is a function which returns an array. We've put the use array into use effects. So this array is now memoized just in the same way that an object would be. So I mentioned that the third most common type of, or third common type of objects in JavaScript are functions. They also are instantiated with their own reference, just like objects and arrays are. There is a way to make useMemo work for functions, but it looks kind of weird because you have to wrap the function within another anonymous function to make it work. So instead of that, React has given us some syntactic sugar and given us another utility method called useCallback. And useCallback just works exactly the same way as useMemo, except it's used with functions. So here we've got our add1 functional component, and it's maintaining a piece of state called count, and then it's got a function in it called increment, which obviously just adds 1 to whatever the count is, and we've wrapped that in a useCallback method. So now you can see that our useEffect uses the function as its dependency, and again, because it's been memoized, it means that in this contrived example, the useEffect is only ever going to be called once on the initial render, because every time that add1 is re-rendered and the code is rerun, our useCallback method is giving us back exactly the same function reference as recreated on the initial render, which means that the dependency of useEffect is never changing, which means that it never gets re-triggered. Okay, so that's already kind of a lot to take in. So we've discussed how useMemo allows you to store the result of expensive calculations between renders, and about how it saves object type references between renders to prevent triggering dependency arrays unnecessarily. Again, both of these are called performance optimizations because they're not strictly necessary in order for your code to work. And most of the time, they're not even necessary for your code to be fast. So there's one other major memoization utility that React offers you, and that's memoizing entire components. So at the top here, we've created the definition of a functional component called countButton, which takes a prop of a onClick function and a count function, and it just shows that count as the label on the button. In our dual counter function here, at the bottom, you can see that we're returning 2 of these count buttons, and the dual counter itself is maintaining the state and the onClick function for both of them separately. So we've got the first one, which is count1. We've got the increment, which is just adding 1 to the count, and then we've got count2 and increment2. So what would happen when either of these buttons are clicked? Let's say the count1 button is clicked. So it triggers its increment1 function. It adds 1 to the count1 state. Now, because the state of dual counter has changed, that causes it to re-render, right? So the re-render causes both children to re-render. So the count1 button now shows 2 if it started off as 1, and the count2 button still just shows 1 because we haven't clicked it yet. But the count2 button still re-renders because its parent dual counter re-rendered, right? So this is where the next memoization utility comes into play, because maybe you don't want the second count button to re-render just because the first one did, because nothing about the second count button has changed. So why does it need to go to the trouble of re-rendering, right? And by the way, it's even though this example looks fairly contrived, why wouldn't each count button maintain its own state and increment, which is obviously what you would do in a real scenario if you were using count buttons, and then they wouldn't affect each other. I've lifted the pieces of state into Ken has lifted the pieces of state into the dual counter parent component unnecessarily in this example. But there are obviously lots of examples where a parent will have different children components, and some of them will have state in the parent, and some of that state won't affect all the children and that kind of thing. So whenever the parent re-renders, all the children re-render, and you may want to try to avoid that. Confusingly, the utility function for memoizing entire components is called memo, which is completely different to the useMemo function that we saw earlier. They're different utilities. So all that I've done is wrap the count button in this memo function. And the way it works is that you literally just plonk your functional component directly inside this react.memo wrapper. And then the component will only re-render if one of its props changes. Now we have a scenario where if we click increment 1 on the first button, dual counter, the parent component, re-renders because its state has changed. Count button 1 sees that its prop count has changed from 1 to 2. So it re-renders correctly. It's to show the new count of 2. But theoretically, count button 2 does not re-render because neither its onClick nor its count props, none of its props have changed. So therefore, React should say, oh, nothing's changed. I'm just going to give you back this component directly without re-rendering it. However, unfortunately, that is not quite what happens, and our memoization has failed to work correctly in this example. I will give you a minute to see if you know why, can figure out why. And I'll just say that, again, we know that the component will re-render if either of its props change, even if it's been memoized. Okay, so the reason why that doesn't work is because every time dual counter re-renders the parent component, as I said, all of its code reruns, which means that both of these constant functions gets re-instantiated, meaning that they change reference, right? Their references are now new, which means that even for count button 2, it thinks that its onClick function prop that it's been passed in has changed because the new reference is different to the old reference. So in order to avoid that, we now have to wrap both of the functions in our memoization technique, use callback. So now whenever dual counter re-renders, they're going to remain as the same reference. You can see that their dependency array is empty, meaning that they get memoized on the first, they get called, and the set count gets instantiated on the first initial render and then never again. So now every time dual counter re-renders, we get passed back the same initial reference and it's never re-instantiated. So if you can think about that multiplied by every possible parent component and every possible prop in your entire React tree that could be feeding into these child components, it's very, very easy to miss memoizing just a single piece of data, a single prop, which would cause your child component to re-render on every single re-render of its parent anyway, which eviscerates the entire point of the memoization. So you can probably tell that I'm creating a very smooth segue into the second part of this talk called You Ain't Gonna Need It. So before we get to that, let's just revise again what we've done. So we have examined two major things that React allows you to do when it comes to memoization. One is memoizing to avoid expensive calculations, and the other is memoizing components and other things, objects, to prevent unnecessary re-renders of components. One example I could think of where it may be worth your while to do this is with heavy types of components such as graphs, animations, that kind of thing, maybe interactive ones. But the important point about that is you only want to use it when the inputs to those graphs, animations, whatever, do not change with each new render. Because if the prop is changing on each new render, let's say if the graph changes based on the person typing into a text box, then that is changing on every re-render and the memoization is useless. One example I thought of is, what about if you have a website that shows some kind of graph or animation based on today's date? Then that, even as the person is moving around the rest of the website and as maybe different parts of the website are re-rendering and stuff like that, that prop only changes once every 24 hours. And so if your graph is based around it for some reason, so that would be a good example, I think, of a heavy type of component that is expensive to render with an input that rarely changes, right? There's a word of caution that I've taken directly from the React docs. If there is no perceptible lag when your component re-renders, memo or use memo are unnecessary. Oh, and if you haven't checked them out yet, React released a whole flashy new set of documentation like fairly recently, and it looks great and is very readable, as you can see here. So they have a whole section on memo and use memo, which you can check out whenever you want, obviously. And so, for example, they have questions like this: should you add memo everywhere? And the TLDR of what they say throughout that is basically no, you shouldn't. But why not? What's the harm? So there's actually not really too much of a big performance trade-off into adding memoization everywhere. There is one performance trade-off though, which may or may not be important for your project. If you have created memoization throughout your entire React app everywhere, then you're asking React, when it first renders the entire application on the user's browser, that it needs to go through the entire application and create caches for every single place where you've used memoization, right? So that's creating more of a load on the front loading of your app when the person first opens the application, which is usually the biggest pain point for React applications, right? Because it's such a huge JavaScript download and setup. So an instantiation. So that actually may be the place where you most want to avoid adding more memory and performance lag onto your application. So that's definitely something to keep in mind. But even if that isn't a problem for you, or it doesn't create more of a performance lag, I'm sure you've noticed throughout all the examples I've given here that adding memoization adds a ton of complexity to the code. It really obscures the code, and it's actually very difficult to get it right. It's easy to forget or not realize that you need to memorize a single part of a memoized component, which makes the whole thing useless. It will just re-render every time anyway. And again, even if you're confident that you can do it all correctly, are you confident that every developer on your team that touches the code and comes later on and that kind of thing will be able to maintain it? And you're adding a whole bunch of extra kind of mental difficulty onto your project. There are, however, some teams that take the approach of, we will just memorize every single thing in our code base, all components, all objects, arrays, functions. Therefore, we won't miss anything because absolutely everything is memoized. And hopefully it will save us some, we're just taking the bet that it will save us some performance gains. The React documentation says like you're welcome to do that, obviously, but they don't recommend it. And I guess I'm going to trust the official documentation. So Kensey Dodds, a wise React man, once said, most of the time you should not bother optimizing unnecessary re-renders. React is very fast, and there are so many things I can think of for you to do with your time that would be better. In fact, the need to optimize stuff like this is so rare that I've literally never needed to do it in the 3 years I worked on PayPal products and the even longer time that I've been working with React. Instead, they advocate for cleaning up your React code as much as possible first before trying to apply performance optimizations. So it's beyond the scope of this talk to go into detail about all the ways you should be using React correctly. But we already saw one, which is here correcting dependency arrays. So instead of using objects and functions and arrays in your dependency arrays, try to use primitives where possible. Another thing I can think of, which we kind of alluded to a bit with the dual counter component, is that you should lower all of your state that you're maintaining as far down the tree as possible. So obviously, you've probably all heard of lifting state. Sometimes you have two children that both rely on the same piece of state, and that needs to be put into the parent. But if it doesn't need to be put in the parent, you should be working to move that state back down into the children if it's been accidentally moved up or things have changed or whatever. Because if you think about it, the higher up in the tree the state is, the more child components are going to re-render underneath it when the parent re-renders when that piece of state changes. So the lower down the tree you can put it, the fewer child components are re-rendering. So that whole idea is called collocation. And there's other stuff like that as you gain more experience with React that you get used to about things that they recommend. Okay, so some tips. If you feel that your code is as clean as it can be and you're sure that memoization is what is needed to make your web app faster, the most important thing you can do is actually measure the performance before and after the change. Because as mentioned, it's very easy to get it wrong. And also it may not even help with performance. You may have a different problem that you need to sort out that's not based on memoization. If it doesn't measurably improve the performance, then you shouldn't use it because, as we've seen, it comes at the cost of making the code much more complex. So what are some ways you can measure performance? So the React Dev tools give you this profiler that will show you when your components are rendering, how often they're rendering, how long it takes them to render, that kind of thing. Another idea is that if you're measuring expensive calculations on the front end, then do a console log for the time before and after to see how long that calculation takes. And then once you've made the change, see if it's really cut down on that time. And the other important part of that, of actually doing measurement experiments in the wild for your project, is that you should be trying to emulate your production environment as much as possible. Make sure that you've actually, try to use a machine that's kind of similar to what your typical user will be using. In order to emulate that, you could simulate that, you could use throttling. And then also you should be using the production artifact of your program, not your development environment of the program, because they're going to have different things going on, basically. Okay, hopefully you've learned more than enough about memoization in React, hopefully enough to be the dissenting voice about the creep of memoization hooks throughout the entire code base, because a lot of the time they're not necessary. That's not to say they're completely useless by any stretch, but they should always be used in a measured and a careful way rather than just as a default. Thanks.